Hello, today I want to talk to you about dynamic processing and in particular about gates, and I will be showing you how to manage them in Logic Pro. This is part of an introduction to music production, a course given by Lance Stearns at coursera.org. My name is Benigno Calvadiego and I'm from Zaragoza, Spain. So today I want to show you a little bit about gates, and the first thing would be, when would you be using one? What's the main use of a gate? The second part that I want to show you is what are the main parameters that you have to know how to manage within a gate to control it. And I will be showing you this through an example. So let's go first into Logic. Now, why would I be using a noise gate? So you would be using noise gates in those cases in which you have low noise that you want to get rid of. Now I mean a noise when there is no signal actually sounding. So if, for example, you're recording vocals in between sentences, in between words, or if you're recording a guitar in between chords, or when you're not playing, you get a lot of noise from the drive, and you want to get rid of all that. So for those instances, you would be using a gate. So let's have a look at the different parameters that you need to be able to control within the gate. The first one would be, and first of all, the name gate is a great analogy because it actually opens and closes a door to the signal. Okay, so there is a signal coming and I'm going to let it in when the signal is above a certain level, and I want to close the gate when the signal is below a certain level. Now, that level that I'm talking about is what we call the threshold. So if I set it here, I'm saying, okay, let the signal in if it is above minus 22 dBs. Whenever the signal is above this threshold, I will open the gate to let the signal in. Whenever it is below this level, I will close the gate. Now, the reduction is the amount by which I will be closing the gate. Normally you want to close it completely, but you might want to let some of the signal come in. Normally the main use, you will be setting it here. Now, the attack, hold and release, those are times. And continuing with the analogy of the gate, the attack time is the time it takes you to open the gate. So whenever the signal is above the threshold, how long will I take to open that gate completely? That's the attack. Now the signal goes below the threshold. How long am I going to take to close the gate? And that's the release. And the hold is a little bit special. Hold is telling the system, okay, if I have opened that gate, then leave it open at least for 100 milliseconds. Now the hysteresis is something that I think it's worth an extra explanation. So hysteresis cycles are a standard way of describing a two-state flow which is controlled by two different levels. Okay, so far I've talked about the threshold as a single level, but if you set a hysteresis, if we set, for example, imagine we set minus 22 dBs, this would be minus 22 dBs. Okay, imagine this point is minus 22 dBs, and then when I start opening the gate, imagine the gate is open, and now the signal starts descending. It goes to minus 22 dBs, but I still don't close it, and I will close it only when it's below minus 22 dBs. And how much below is given by this. So if I say minus 2, then I would be saying don't close it. Once you're open, don't close it until you're at minus 24. And now keep it closed. And now the signal starts growing again. We get to minus 24, nothing happens. We get to minus 22, it still doesn't open again, and we get to the minus 22 plus the 2 of the hysteresis, and we get to minus 20, and at minus 20 it will open again. Now, this gives us some sort of a free zone where the signal might be changing within these 2 decibels or 4 decibels. It might be changing here, but it won't be opening and closing the gate all the time. And that's very useful because at times it's very difficult to find the exact level of the attack and release so that you don't get an effect that it's called chattering. Okay. Now, the high cut and low cut are just a couple of filters that let the analysis of the envelope be applied instead of over the whole spectrum. You might say, okay, I just want to check my signal, the level of the signal between these 2 levels. And this way you might fine tune when it opens and closes. Or you might want to apply more effects. This button here, monitor, it helps to listen to a side chain if you have one. And the look ahead is basically so that the system sees the signal before it comes, so to say, so that it reacts more quickly. Okay, so those are the main parameters that you need to know. But the most important ones: threshold, attack, release, the reduction that you will normally set to the minimum. Those are really the important ones. Hysteresis helps a lot. Okay, so let's have a listen to a piece, to part of this signal and the problem I have here. Okay, can you listen to it? At the end of that, I have some noise. So now what I would do is, first of all, I usually set a level meter just before the effect I want to, just before the dynamic, because these plugins don't show you the levels, and that's a little bit of a pain. So you need to enter a level meter just before them so that you can see the level. And you could also create another one just after them if you want to see it before and after the plugin. But right now, what I'm going to be looking at is the peaks. Normally, I'll start by having the threshold all closed or all open and start moving it. If it's all closed, you don't hear a thing. And now we start pulling it down. As I've seen here, at -6 or -8, I'll set this to 0. -6 or -8. Okay. Okay, have you heard that? That's the chattering I was talking about. It gets those -8, but as it goes up and down, it opens and closes. Now, I have set a long release because it's actually a long release and I don't want it to be abrupt. If I do it like this, there are more chatterings and it's very, very abrupt. So I want to have it long here. The attack I don't mind so much, but I could set it longer also. And my problem really is that it's very close to the signal. Here, I could maybe see it -6. A little bit too brusque. So maybe with a little bit of hysteresis, I fix this. Now I'm going to check on the rest of these parts here. Could be problematic. No, great. Well, I think that more or less covers the concept. I hope that it has helped you a little bit. And I leave you with the little piece that I was writing here. Thank you for listening.